Okay, so this is the Junior Certificate Higher Level Maths Paper 2 for 2018, and I'm looking at questions 9 and 10. So question 9 here, the diagram shows the rhombus QRST. It is a parallelogram in which all four sides are equal in length. The diagonals cross at the point K. Two of the angles are marked X and Y. So we have Sanjay, who is trying to prove that the triangles QKT, that's QKT, this triangle here, and SKT, which is this triangle here, are congruent. In other words, they have the same size angles and the same size sides. Fill in the missing statements and the reasons in the table below to complete Sanjay's proof correctly. So the first one is done here. First of all, it's saying that QT is equal to TS. This side here is equal to TS here, because QRST is a rhombus, so all four sides are equal. So he's saying this side here is equal to this side here. Second part here is saying that QST is an isosceles triangle. QST is an isosceles triangle. The reason for that, then, what would we write down for the reason for that? Well, we can say that, well, we've kind of said it here, QT is equal to TS. QT is equal to TS, so it has to be an isosceles triangle. So we could repeat that. QT is equal to TS. So what we're saying here is that two sides of the triangle, two sides of the triangle QST are equal. So that's it. QST then must be an isosceles triangle if QT is equal to TS. Two sides of the triangle are equal. Okay, third one. The angle X is equal to the angle Y. So this angle here is equal to this angle here. Well, that's because this is an isosceles triangle. We know this side is equal to this side, and we know then that the angles opposite the equal sides are equal in size. So that side is equal to that side. So the angle opposite this side is this angle here. The angle opposite to this side here is Y. So therefore X must be equal to Y. So we're just going to write that in here. The angle, let's see, how do we put this? The angles opposite the equal sides are equal. So the angles opposite the two equal sides are going to be equal. Part 4 here, the reason given is the diagonals of a parallelogram bisect each other. So what would this statement be? Well, if this diagonal and this diagonal bisect each other, we're talking about these two triangles here, so we really must be looking at this side here and this side here being equal. In other words, QK must be equal to KS. So QK must be equal to the side of the size of KS. QK is equal to the KS. Therefore, QKT is congruent to SKT, and the reason for that is side angle side. So we've shown that this side is equal, these two angles are equal, and then these two sides here are equal. That's a side, this is our, this is our side here, this is our angle here, and this is our side here. Okay, so that's it for that question. Let's have a look at question 10. So in question 10 we have a staircase here. Grace is putting some stairs into a new house. the diagram on the right shows 3 of the steps in the stairs. Each step consists of a riser and a thread. So you've got this riser is the vertical part of the stairs or the step, and the thread is the horizontal part of the step. Each step consists of a riser and a thread. All of the risers in the stairs are the same size as each other, as are the threads. The table below shows some measurements for stairs in private and public buildings. The optimum length is the best possible length. So we have the thread here, and we have the riser here. We have private buildings here and public buildings here. We are given a minimum measurement and an optimum measurement for each. So Grace's stairs will have an optimum size step for a public building. So for a private building, I should say. So here's our private building measurements along here, and she will have an optimum size step. So we're looking at this measurement here, 250 and 175. So 250 millimeters thread and a 175 millimeters riser. Grace's stair will climb a total vertical height of 2.1 millimeters. Grace's stairs will climb a total vertical height of 2.1 meters, I should say, and this means the sum of the risers is 2.1 meters. Work out the horizontal length of Grace's stairs, in other words the sum of all the threads. Excuse me. So what we're going to do here is work out how many risers there will be first of all, and from that we'll know how many threads there will be. So how do we work out how many risers there will be? Well, we know that the sum of the risers is 2.1 meters. So our riser, we know it's an optimum riser for a private house, so it's 175. So it's 175 millimeters. So these are our risers. Now 175 millimeters is 17.5 centimeters, which is 0.175 meters. So I've just converted it to meters here, because we're talking about the sum of the risers being 2.1 meters. So all of these risers add up to 2.1 meters. So if we take 2.1 divided by 0.175, we'll get 12. That means there are 12 risers in Grace's stairs. 12 risers in Grace's stairs. So that means there must be 12 threads as well. So that means there are 12 threads. Because for each riser there must be a thread to make a step. Riser, thread, and so on. So that means all we've got to do is look at the size of the thread. The thread is 250 millimeters. Let's just convert that to meters. So it's 200, and this is the thread now. It's 250 millimeters, which is equal to 0.25 meters. Now we have 12 of these, so you got to take 0.25 and multiply by 12. That gives us 3 meters. 3 meters, and this is the horizontal length. The horizontal length of Grace's stairs. 3 meters. Okay, so let's have a look at part B then. Now, the angle of elevation of Grace's stairs is marked A in the diagram on the right. So it's this angle here. So you can see we have right angle triangles up along here, and we know this distance here, and we know this distance here. So we can work out angles here and so on, or side lengths if we need to, using trigonometry or Pythagoras' theorem. Let's see what we're asked to do anyway. Okay, well, it says use trigonometry, and without measuring work out the size of the angle A. This is in Grace's stairs. So let's have a look at this A here. It's just forming a right angle triangle. So we have this here. I'll just explain what these side lengths are. So in other words, all I've done is drawn a right angle triangle here, along here like this. So this is the triangle I've drawn, and I put A in here. So what's this length here? Well, this would be the riser of Grace's stairs, and we know that that's 175 millimeters. That's 175 millimeters. Now, what about the thread here? Well, this distance along here for Grace is 250 millimeters. So all we've got to do now is work out the angle A, and what we're going to use here is opposite over adjacent, which is tan. So I'm going to take the tan of the angle A is equal to the opposite, which is 175, over the adjacent, which is 250. So to find the angle A, then we just do tan inverse of that. So that means the angle A, so in other words the size of the angle A there, is just going to be tan inverse of 175 over 250. That's just calculator work then. So we have the size of the angle A here is 35 degrees. 35 degrees. This is to the nearest degree, which is what we were asked here. We're asked to do to the nearest degree. Okay, so that's part B. So let's have a look at part C then. Okay, write down the length of the thread and the riser that would give the maximum angle of elevation for a public building. So what we need to do here is we need to have our right angle triangle such that A is here, and that this side here will be a maximum. This side here will be a maximum, and this side here, the adjacent, will be a minimum. So we want to make this side here as small as possible, and this side here, the riser, as big as possible. That will give us our biggest angle. Okay, so what's the maximum and the minimum riser and thread for a public building? Let's have a look back at our table that we were given back here. We're looking at public buildings. We need a minimum thread. So the minimum thread is 280 millimeters, this here, for a public building, and we need a maximum riser which is 180. So that's the answer to the question, really. So let's just write that down. We need a minimum thread which is 280 millimeters, and we need a maximum riser which is 180. Let's see, anything else we have to do there? Write down the length of the thread and the riser that would give the maximum angle of elevation for a public building, and that's it really. You're not asked to work out what that angle is, but really it's just tan inverse of 180 over 280, and that actually gives you an angle of 33 degrees. You're not asked to do this. This here is the actual answer here. Okay, so that's it for questions 9 and 10.